Hello friends, continuing with the topic of electric dipole, today we derive an expression for electric field intensity due to an electric dipole at any point on equatorial line of the dipole. Let us develop the physical situation first. Consider an electric dipole consisting of two charges plus q and minus q, separated by a small distance 2a, such that its dipole moment P is equal to q into 2a, and mark it as equation number 1. Let P be any point at a distance d from the midpoint of the dipole where EFI means electric field intensity, is to be determined. Now we proceed further for electric field intensity at P due to plus Q. In the second point, we write the expression for electric field intensity at P due to plus Q. Say E plus equal to K naught Q by R square, where R is equal to under root D square plus A square. Direction is along Px. Okay, now we write the expression for electric field intensity due to minus Q. Now electric field intensity at P due to minus Q, say E minus. This arrow shows E minus. E minus is equal to K naught Q by R square, where R is equal to under root D square plus A square. Again, why it is the same? Because PC is the right bisector of AB, axial line. So PC is the right bisector of axial line AB, and so PB will be equal to PA, and angle PBC, if it is equal to theta, then angle PAC will also be equal to theta. Okay, now we come to the resultant of electric field at P. Because the two fields E plus and E minus are acting at P, so we have to take the linear vector sum of the fields that will give us the resultant. Now how we find the resultant of the field? First we resolve E plus and E minus into components. So components of the fields. The fourth step, we are to write the components of the fields E plus and E minus. So first we take up E plus. Now E plus can be resolved into two components, E plus sine theta along Py, and E plus cos theta along Pz. Because angle XPZ is theta and is the corresponding angle to PAC. Also angle ZPB is theta because it is alternate angle to PBC, because PZ is parallel to AB and PB intersects. It is a transverse, so these angles would be same. Now similarly, E minus can also be resolved into two components, E minus sine theta along PC and E minus cos theta along PZ. So this is how we resolve the components. E plus two components, E plus sin theta along Py and E plus cos theta along Pz. Similarly, we can resolve E minus into two components, E minus sin theta along PC and E minus cos theta along Pz. Now, how we go to resultant? Now let us see. The resultant electric field at P. Now consider first perpendicular components E plus sin theta along Py and E minus sin theta along Pc. They are equal in magnitude, opposite in direction, cancel each other. Now E plus sin theta, E minus sin theta, they are equal in magnitude, opposite in direction, and their line of action is same, so they cancel each other because they are equal in magnitude, opposite in direction. Okay, so their line of action would be same, so they cancel each other. So therefore, resultant field, whatever resultant field is there, that is due to E plus cos theta plus E minus cos theta, because both are acting in the same direction. So these two components, addition of these two components will give us the resultant of electric field at P. Because both are in the same direction, the angle between E plus cos theta and E minus cos theta is 0. So the resultant will be the addition of magnitudes and the direction will be along Pz. So resultant field at P, E equatorial, that will be equal to E plus cos theta plus E minus cos theta, and it is equal to 2 E plus cos theta, or you can write also 2 E minus cos theta, being same in magnitude and direction, and is opposite to dipole moment vector P, that is axis of the dipole. So E equatorial will be equal to 2E plus cos theta along Pz. Now substituting the values of E plus and cos theta, we get E equatorial is equal to 2 K naught Q by R square into A by R. K naught Q by R square is E plus and A by R is cos theta. So we have 2 K naught 2 AQ by R cube. Now we substitute the value of R equal to under root D square plus A square. So we get E equatorial as K naught P divided by under root D square plus A square within bracket power 3, or we can write it as K naught P divided by D square plus A square within bracket power 3 by 2. Now 2AQ is P. 2AQ we write it as P, dipole moment vector, because P is equal to Q into 2A. Okay. So thus finally we get E equator equal to K naught P divided by D square plus A square whole power 3 by 2, and direction would be opposite to dipole axis, parallel to it, or NTP. It means the direction between E equatorial and E axial is 180 degree. Now we discuss the result. In discussion, we see when dipole is a point dipole, that is A is very small as compared to D, then A can be neglected in denominator. Here A can be neglected in denominator, and after neglecting A, the expression reduces to the form E equatorial equal to K naught P by D cube, and it is half of the field at any point on axial line. That is, E equatorial is equal to half of E axial, and the direction of E equatorial is opposite to E axial. So you remember these technical points regarding electric field intensity at any point P on equatorial line at a distance d from it in air. Assignment 1.4 continued. Question number 8. An electric dipole of length 0.1 meter consists of two charges of plus minus 500 microcoulombs. Calculate its electric dipole moment. Also calculate the electric field intensity at any point on equatorial line of the dipole at a distance of 0.2 meter from midpoint of the dipole in air. Question number 9. 2-point electric charges plus minus 10 microcoulomb are placed 5 millimeter apart. Calculate electric field intensity at a point on equatorial line of the dipole at a distance of 15 centimeter from midpoint of the dipole. So in question number 8 you use the full-fledged formula, and in question number 9 you use the second formula where A is very small as compared to D. You draw the diagram and understand and look into it. Okay, you solve these two problems on the basis of the text that you have learnt. Thank you so much. God bless you.